Hey, Deidre. Hey, Brittany. Can you hear me?
Yeah, I can hear you.
I can't hear y'all. Let me see if I.
Can you hear me?
Hey, Samantha. Can you hear me?
Hello?
Hmm.
Can you hear me?
Oh,
Hello?
I can hear you. Hello?
Okay.
Why-
Can you hear us, Samantha? Oh, there we go. I can hear you.
Okay.
Brittany, can you hear me? Deidre, can you hear me?
I can hear you.
Perfect. Thank y'all. Okay, so first of all, let me say on Thursday, I have this reminder for myself. You need a device. You need a laptop, an iPad, probably something more than a phone. We're have a GeoGebra day. So we're gonna do it all in class on Thursday. So you need some sort of device on Thursday that you can do class on a computer, iPad, whatever. So this is your notice to bring that on Thursday. I just passed out to the class this sheet. Those of you that are online, this sheet is under week 5. I updated all the stuff. So on week 5, it says properties of quadrilaterals. And that is the sheet that we're about to go over right now. Also, you have 2 homework assignments out right now. This is section 1.5 and 1.6. This is bookwork, and it has the page numbers and problems from the textbook. I think I talked about this last time. Did we talk about this last time? It's like I can edit the due date, it doesn't matter. Actually, this is super fast. Like this is very simple triangles and quadrilaterals. Okay, so like super duper simple. The other homework though is this 5.1 through 5.3. This is also a book assignment, and this is more of the quadrilateral, like use this to find this angle, those sorts of things. Okay, you have 2 homework assignments, and both of those are on D2L, but they're both bookwork, so it's all typed up there for you.
So I really need the book, don't I?
Yes, you probably should get the book by this point.
Yeah, she thought one, so I'll have it.
Questions about that? Okay, so this was kind of what we drew last time, talking about quadrilaterals and how you could classify them. And if you turn it over on the back, these are all these are not definitions. These are characteristics that we kind of started proving last time. So we are spending the next, let me kind of give you a heads up on the calendar. We're spending the next good bit on proofs. Okay, so today's date is, here, I'll do it on this. Today's the 26th, so the 26th, then we have the 28th, then we have the 3rd and the 5th, and then the 10th and the 12th, and then the 17th. Your test was supposed to be on the 12th. I'm going to bump it to the 17th, if y'all are okay with that. Do you have your pre-cal test on that? Is it on the 17th? I don't want to like double you up on tests, but okay.
Yeah, it's on the.
Okay, so we're gonna make exam number 1 on the 17th. We are going to review on the 12th. And we are doing proofs every other day except for this day. This is GeoGebra day. But we're doing proofs on all the other days. So just heads up, exam number 1 is going to be on the 17th. Questions about that? Okay, so last time we started proving some things. I'm trying to figure out, we wrote down all our stuff, right? And is that the only paper I have? And then we I have this paper, started proving things. So we had a kite. And the first thing we proved on a kite was KLM and KNM are congruent. So non-vertex angles are congruent was the first thing we proved. So we were right here. That was number 3. Exactly one pair of opposite angles are congruent. Okay, so we proved that. And then the next thing, I think I cleaned up my folder. I think I threw away the last page that we were proving things on. The next thing we proved was, do you remember? Yep, the diagonals bisect each other. And unfortunately, I do not have that paper, but the diagonals bisect each other. We did that. Oh, the diagonals bisect the vertex angles actually. And then we did we go into diagonals bisect each other? No. Is this the last thing we wrote? Oh, good. Okay. I didn't lose paper then. We're good. Okay, so we talked about how the diagonal bisects the angle. So we talked about this angle is congruent to this angle, and this angle is congruent to this angle. So the next thing we can talk about, which you can kind of look at your paper. Number 1, both pairs of consecutive sides are congruent, but opposite sides are not congruent. That's like the definition, right? A definition of a kite is a quadrilateral with no set of parallel sides, and then 2 adjacent congruent sides, right? So this is the next one we're going to prove, number 2. Diagonals are perpendicular. So let's go back over to our picture. And let's up here at this picture that we worked with last time. Where's the diagonals here? Yeah, LN is a diagonal. KM is a diagonal. And we're trying to prove they're perpendicular. How can I prove that they're perpendicular?
Use a triangle
Yes.
probably.
Mm-hmm. Okay,
What did you say?
using triangles.
Just saying, if we know that the angles are equal, then wouldn't that make the line go?
Which angle? Oh, if you knew all 4 angles are congruent? Or what? What were we
I
saying?
was saying like, those 2, I don't know what to call it. If these 2 angles are congruent, does that not make the line straight?
So he said, if these 2 angles are congruent, could I use that to figure out stuff about these angles? We actually don't know about if these angles are congruent also. So you could, like, the idea is you'd have to subtract from 180. And you could not figure that out. Because it doesn't bisect it this way, it only bisects it this way.
Well, you can use the triangle K and L, the isosceles triangle we have.
Which one?
K and L, like using the diagonal going from L to N, like that whole thing.
This whole thing right here? Okay, I like it.
So it's an isosceles triangle, so
Mhm.
you can, those angles,
Oh.
and then another.
So she said this right here is an isosceles triangle. I agree. So the base angles are congruent. So this angle's congruent, this angle's congruent, this side is congruent. So these 2 triangles are congruent by angle, side, angle. I concur. I agree. How does that show that this is 90 degrees? Because perpendicular means this has to be 90 and this has to be 90, right?
Yeah.
It actually does show that, but I'm trying to get y'all to see that.
Oh, does it show that?
Mhm.
Well, if you know that those, the other angles are all place 2 equal triangles, I don't know.
Could you use their bisectors? Because each bisector is a straight line.
Yes, each bisector is a straight line, but I don't know if they bisect like this, like what angle they bisect
Okay.
at. It looks like they do, right? Let me break this part into two separate triangles like this. Oop, that's not a very good picture, but we know these are congruent triangles. We can write that down in a minute, but we just talked about it by angle, side angle. They're congruent, agreed? So that means this angle is congruent to this angle. It means this angle is congruent to this angle. And it also means this angle is congruent to this angle. Yeah,
And when you put those together, then they have to equal 180 because they're linear pairs.
there you go. So since these are congruent and they also are a linear pair, they have to be 90. There's no other option. There's no two numbers that add together. No number multiplied by 2 that gives you 180, right? So let's write all that down. We're gonna write a paragraph
Yeah,
proof for
that's
this.
the question of how.
So we're on, so again, today we're gonna do more paragraph proofs. Next time, we're gonna move into a more stricter version, which is called the flowchart proof, and then we'll do into your 2-column proof. So we're going to spend the days, not next time, that's GeoGebra, but the time after that. So if I labeled my 2 triangles, this was K, L. We need a letter from the middle right here. What do you wanna call that?
P.
We already have an N, a P. So KLP, and we have a KPN. And let's write the things, like the stuff I have on this picture is things that we know after we prove all this. So we're going off based off of this picture up here. So what do we know based off of this picture up here?
We know that. Well, should you say that K and L are, isn't this also?
Sure.
Because that's how you know that they.
So triangle KNL is an isosceles. I think I spelled that wrong.
That's what we.
No, it depends on the day. Some days it's all right. Isosceles triangle.
You have to put why we know that.
Mm-hmm. Oh my goodness, I can't spell anything. Triangle. Why do we know it's an isosceles triangle?
Besides KL and KN are either.
We're trying to prove angle, side, angle. So we have to show the angle, we have to show the side, we have to show the angle right now. And we're about to show the sides by, because KL is congruent to KN. And again, how did we know they were congruent? Because the picture says so.
Can we say, I mean,
It's kite. What do we know about kites?
that they're, the adjacent, well. Consecutive sides are congruent.
Mhm.
So can we just put by definition of. kite?
Definition of a kite. Yeah, we know these are congruent because that's literally what a kite is.
And then by definition of an isosceles triangle, we know that angle L and angle N are equal.
Pause real fast. I'm going to, as we go through this, we know these sides or these triangles are congruent by angle, side, angle, agreed? So I need to show 3 things. I need to show an angle, I need to show it a side, and I need to show an angle. So what did I just show right there?
An angle. I mean, I'm sorry, it's fine.
We just showed a side right there with that piece. I'm gonna kind of like write it down as I go through. So now I need to show this angle KLP is congruent to angle KNP. Okay, so now I can say angle KLP is congruent by angle KNP. And this would give you my other angle part. By what? What
By
words?
definition of an isosceles.
This is the biggest mistake that people make this semester. So real fast, I'm gonna pull out my word bank that you get to use on your test. Because this is like if you were taking a test, this is where you would be looking for your stuff, right? So I'm going to use this isosceles triangle stuff. And she says that these angles are congruent by definition of an isosceles triangle. What's the definition of an isosceles triangle?
Like opposite corresponding. What's your point there?
So the definition of a isosceles triangle is that the
Oh,
sides are
okay.
congruent, right?
Okay, so what about the converse of, wait. Isosceles triangle conjecture?
That's what it is. So so I did not give it to you today. I feel like I could give it to you now, but I don't want to scare you. So we're about to have a big, huge proof homework. And like after these 2 homework assignments, we're not gonna have any homework until your next test because you're gonna be working on this big proof assignment. But it's 12 proofs that you're gonna do, I say on your own. I will assist you and I will help you out and pull you through them, okay? But one of the first ones is proving if it's an isosceles triangle, then the base angles are congruent. So that is called the isosceles triangle conjecture. And you'll see that in a week. I'll probably wait till next Tuesday to give to you. I don't want to scare you off yet.
And
So-
that's you prove that those same.
Uh-huh. Yeah, so we're going to do that. So that is, so this is congruent to that by isosceles triangle conjecture. And you can abbreviate as much as you want to here, as long as I can still, I don't just put one letter. But as long as I know what it would be. Okay, so that just got,
You say ITC, or is that not
make it say isosceles and then TC. I'm fine with TC as long as you write isosceles or put that version of it. So that was an angle. Which angle is that? We just got the top angle, the top and the bottom. I need a third angle.
just you can do the 90-degree?
That's what I'm trying to prove. That's my goal, is to show that those are congruent. So I have to use this other angle right here. Do I know that these are congruent?
You do, but.
I do. I just proved
you
it.
do because you know that KN,
Mhm.
is the, because vertex angle, because the diagonal bisects, the, yeah.
So we just showed that the diagonal bisects the vertex angles. We just showed that. That was like almost a week ago. But these are congruent because this is an angle bisector, right? So I can say angle LKP is congruent to angle LKP NKP. How do we know?
Well, how do you put that? Can you just prove it or like?
We just proved it and it would be under quadrilaterals
Oh, I see, okay.
on back.
The heights diagonal bisector conjecture or the one for that height angles? Wait, height, oh my gosh, I don't know. Height diagonals conjecture? Height.
If we were sitting here proving these over and over, you could say, see previous proof. Like if we just proved this, right? You could say, see proof number 2 or whatever. The word for this, if I'm thinking about words, I am talking about a diagonal. What's it bisecting? Are the diagonals bisecting each other? No, the diagonals bisect what?
Oh, the vertex, yeah.
A vertex angle, right? So it's not gonna be kite diagonal bisector, because that says something about angle, right? It's not gonna be kite diagonals, because it says something about angle. So kite angle bisector conjecture, that's the one it would be. But again, if you just prove these right in a row, and you didn't know the names for that, you could say, see previous proof. Right. We are still at the very beginning of proofs, but I will say this, the ones we're doing in class are a lot harder than what I expect you to do on a test. So I did an angle, I did a side, I did another angle. So now I can say the triangles are congruent, because I said the 3 statements I had to say. So now I can say triangle. How do you want to name it? KLP is congruent to triangle KLP. NP by what?
by ASM.
By what we just did, angle, side angle conjecture.
Oh, that Ellen bisects Dan, is that what we're trying to prove?
They're perpendicular. We're trying to prove that this is perpendicular to this, and I can do that by showing I have two right angles right here. I'm almost there now. Now I can say those two angles are congruent. Right? So now I can say angle LPK is congruent to angle LPK NPK. By, how do you know? By, and if you can't remember that, remember it's on the bottom. Corresponding parts of congruent triangles are congruent, conjecture, whatever. So CPCTC. And now that I showed that those two angles are congruent, I'm trying to show they're perpendicular. So what am I going to do now to show they're perpendicular?
We're gonna come up and do linear pairs, yeah.
They are a linear pair. Let's think through, do we have any properties or anything that we could say for that?
Linear pair, let's. Linear pair postulate, or do you not say that? Are you saying something specifically under property?
Okay, so could like the idea of what I want to say here is, well, I know they're congruent and I know they're a linear pair, so they have to be 90 degrees. Do I have something that says that is what I was trying to say. I don't think you do. You have linear pair. What is the linear pair conjecture or whatever? What does linear pair mean?
Linear pair means that to be 180.
Add to 180, right? So how am I going to write that here? Good question. She says, tell me how to do it.
So we put the K. Oh. LPK.
Well, let's say they're a linear pair first, okay? So let's say, same thing, so they're congruent and angle LPK and angle NPK are a linear pair.
Do you know how to prove how they're linear pair?
That's the name of, like, by definition, two angles that are on a line. And those are two angles that are on a line.
Okay, and then now you put. What are we trying to prove? That they're perpendicular.
Our end goal is to show that KM is perpendicular to LM. So our end goal is to show KM is perpendicular to LM.
Well,
LN, that's it wrong, sorry.
like now is it like our last sentence, therefore LN, or do we use P? Do we use LP? And
LP.
I mean the LP and PN must be perpendicular.
Okay, so let's kind of work backwards. So if my end goal is to show that they're perpendicular. Move that out of the way. My end goal is to show perpendicular. What does that mean? What do I know about being perpendicular? Perpendicular, okay. How do you know things perpendicular?
A line goes through another line at 90 degrees.
90 degrees, right? So I need 4 90-degree angles to show that they're perpendicular. Agreed? Concur?
Yeah, so do you have to talk about OPN and.
Okay, so right now I don't know anything about 90 degrees. Right now I know they're congruent. So two of the same angles. And then what else do I know? They're a linear pair. So how can I convert these words to 90 degrees?
In order to be the same and be a linear pair, they have to be 90 degrees, but I don't know how to say that. You know,
So let's convert these words to numbers. What does linear pair mean?
180 degrees.
Add to be 180. Yeah. So I have angle 1 plus angle 2 equals 180 degrees. Agreed? So you're saying they have to be 90. Why do they have to be 90?
And they're equal angles, so you have to divide.
Because this right here says 1 equals 2. Right? I should put some angles on there so I'm not saying numbers or. So now couldn't I like substitute one of these in? Be like, put in an angle, which you can substitute either one, doesn't matter. I'm gonna put angle 2 in. So angle 2 plus angle 2 equals 180. So therefore angle 2 has to equal 90 degrees.
Yes.
I guess because you, two angles, they're the same.
Mhm.
How do you say that?
You could just say that it's divided by two angles divided by what a linear pair is, which is 180 degrees.
So if we were doing a 2-column proof, which this is, I believe this is one of the ones that you're actually proving on your homework, is if two angles are a linear pair and they are congruent, then they both are 90 degrees or whatever. So like this is the idea for if you had to like write everything out. If we were saying words, we could say, since they're congruent and add to be 180, then they both have to be 90 degrees.
Can you say that?
I mean, unless you want to sit here and say substitute in da, 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 da. Since they are equal and add to be 90 degrees. Nope, not 90, add to be 180 degrees. Then they each are 90 degrees.
And now you can say. The last one's right.
Mhm.
Therefore,
Therefore, AM is perpendicular to LN.
can you say that, or do you say by something?
Technically, you should say by something. By what?
Can I say? The definition of a.
Yeah, that's what you're gonna say. Was that what you're gonna say? The definition of perpendicular lines?
No, I was just saying because we just wrote it all down.
Yes, I said so. We just gave the definition of perpendicular lines, right? Angles are both 90 degrees. By the definition of perpendicular lines. So we just did this one. Diagonals are perpendicular.
I have a question.
Yep.
So could you
So-
not have just proven that just by saying that lines KL and KN are congruent, LM and NM are congruent, and that the line KN and LN bisect, like, doesn't that automatically make it perpendicular to lines?
Can you start over? Just because I have to look at it and I didn't have my picture. Can you start all that
So
over?
technically, right, like LKN triangle is isosceles, right?
Yep.
And then the other triangle is also isosceles.
Mm-hmm.
But those two lines, LN and KM, we already determined bisect the whole thing.
Bisect the angles.
They created two congruent triangles, yes.
Yes, on top and on bottom, I agree.
So wouldn't that automatically make them perpendicular? Because line KL and KN are congruent, and LM and NM are congruent.
So she's breaking it up into this and saying these are isosceles triangle with base angles that are congruent, right? Because these are both isosceles. And then you're breaking it up this way also. Right, so this was the first thing you said. These are isosceles triangles, correct?
Yeah.
What was the second thing you said?
Well, we already determined that those lines, KM and LN, bisected.
We determined that they bisected the angle LKN and LMN. Is that what you're saying?
Right.
Okay, so
But in
we
order
already,
for them to bisect and for for both those triangles to be isosceles, wouldn't that mean that they has to be perpendicular?
I feel like the answer to that is probably true. But we don't have a statement to say that. And I'm trying to think of like a real life example of this. It's kind of like saying, every person with, I don't know, that wears glasses goes to the eye doctor. Every person that goes to the eye doctor has to pay a bill. So you can automatically say that every person that wears glasses has to pay an eye doctor bill. I don't know. It's like kind of like trying to connect those, which that's probably true. Every person that goes to the eye doctor probably does have to pay an eye doctor bill, but I don't have a proof or a statement saying those two things. And that's literally the hardest part of proving things, like creating a proof. And it's also the hardest part of teaching it is like, we do a lot of logic based on like assumptions, making a lot of assumptions. And this is probably true. I bet there's a way you could prove if you have two isosceles triangles this way and two congruent triangles this way, then this line will always be perpendicular to this line. But the steps you have to do to be able to make that statement, I feel like is more steps than we did here. Even though this is very wordy, I agree. Does that kind of make sense?
Yeah.
It's like you'd have to have a by statement, and we don't have any statements that say two isosceles triangles, if you split it the other way and make it two congruent triangles, then they're automatically perpendicular. Like it's a feeling because it's true. Like this is a true statement. We know, like we were told they're diagonal. We're trying to prove it now. It's just you can't use like what feels right to prove something's true. I don't know if that makes sense or
Make
not.
up our own rules, our own
If
conjectures.
it's not on this paper, then it's not.
Basically, did you say biblical?
I said provable.
Provable. I like biblical. He said if it's not on this paper, it's not provable. That's the idea. The idea is you have to say one of these things is your is your explanation for it. And the reason why geometry is so strict is if you don't do that and you start making assumptions, because remember, geometry started off as 3 words: line, point, and plane, and 5 assumptions about those 3 words. Excuse me, I just burped, sorry. 5 assumptions about those 3 words, and then everything is built off of that. So if you make a mistake on any of this or any of the building, the whole thing crumbles, because this is like the base of the structure, and anything built on top, if this one's wrong, the whole thing like falls down. Does that make sense? So that's why it's so dang picky about proofs. But I will say, this is another annoying thing, is this is not the only proof for this version. You could have proved this another way. That's just the way we kind of worked through it. So if you and another classmate prove things two different ways, it doesn't necessarily mean that one of you are wrong. Does that make sense? It could be, but not necessarily. It's not a guarantee.
The hard part for me is in geometry, like high school, we were told those were facts. We weren't shown
Mm,
that they were facts,
mm-hmm,
if that makes sense. We were just told it's one way. I'm like, oh, okay.
mm-hmm,
We were shown that that's why it's that way.
mm-hmm.
This is the first time I've ever seen.
Explanations of why
one
diagonals
something,
are,
right,
well, that's honestly the point of this class is, like, if you can understand why, then you can teach
sure.
how or whatever. Okay, so we have done all the kite ones. Check. So what would you like to move over here to trapezoids, or would you like to move over here to all of these things? We're not going to prove every single one on this page. We're going to prove a chunk of them.
I just said rectangle.
Can we just do rectangle?
That was like more kind of like a joke, but like kind of like
For real. You want to make it a little better. Let's see.
Watch for things.
Let me see which ones I want to do on all of these.
Basically, every time you go to prove anything, like see how the trapezoid has 2 points, you just need to make sure that those 2 points are covered when you prove it. Is that what their points are for?
So some of this is definition and some of it is points. Here on trapezoid, let's see which one's definition. What's the definition of a trapezoid?
No,
Is number 1. Well, I guess both of them are definitions of it, no?
you said.
This number one's definition. Definition is one set of parallel lines. Right?
On a trapezoid?
Mhm.
Yeah.
One set of parallel lines is all it is. So, this one actually is a parallel line proof. This one's not bad. Let's do number 2. Let's look at trapezoids and talk about exactly 2 pairs of consecutive angles are supplementary. So let's think through what all those words mean. What does supplementary mean? Equal 180. What is consecutive angles?
Like in the same spot,
In the same
like
time.
same.
So it's saying,
Next to each other. Like consecutive
Oh.
numbers would be like number 2 and 3 or 7 and 8.
Oh, okay.
So angles next to each other, exactly 2 pairs means there's 2 specific sets that happens with, not any 2 sets of consecutive angles. So let's draw a picture of a trapezoid, and let our picture of our trapezoid, let's make it not isosceles when we draw it, so that we don't make any assumptions about isosceles trapezoids. Because notice isosceles trapezoids have a bunch of extra new things in it. Okay, so I'm going to draw a trapezoid. So for a trapezoid, you need to draw parallel lines. And I'm going to make mine not isosceles looking so that I don't make any assumptions about it. Let's label it. I'm gonna call it A, B, C, D. And I know based on the definition that that is parallel to that.
So, consecutive would be like A and B and C and D, or would it be? B
So
and
yes,
C?
consecutive. So it is a combination of 2. Is it A and B add to be 180, B and C add to be 180, C and D add to be 180, or D and A? What do you think?
Well, because the parallel line to
It's the 2 that are in between the parallel lines. So like these 2 and these 2. So the ones that follow this are the ones in between the parallel lines. And if we kind of think through take our picture, I'm going to extend my angles. Nope, extend my lines so that I can kind of see some parallel lines here. And I can kind of see some transversals now.
So it's like,
So I'm gonna zoom out of this a little bit and let's write out the proof. What's our goal here? What are we trying to show?
we're trying to prove that those sides are, we're trying to prove they're parallel.
We're trying to prove
angle A and B had to be,
180.
yeah.
Okay, so my goal is to show angle A plus angle B equals 180. Inversion of the trapezoid is angle A plus angle B equals 180. I'm going to go ahead and use three letters above it, just since I have different lines, it's kind of confusing which side of those A and B. So that would be DAB, angle DAB plus angle CBA equals 180 degrees.
We're trying to prove.
I'm trying to prove that. That's our goal. And real fast, this is a technical thing that you'll start to learn is when we have an equal sign with the degrees, we have to say an M, the measure of that angle. The measure of that angle equals 180, or the sum of the measures of those two angles equals 180. Okay, so again, up in my picture, I'm trying to show that those two added together equal 180. So let me start off with what I know. What do I know based on the definition of a trapezoid?
AD and BC are parallel.
AD is parallel to BC by definition of a trapezoid.
No, we have that BA is a transversal of vector.
Mhm. Yep, BA is a transversal.
So can you put that down?
Sure.
Or can you put because BA is a transversal
Yeah, that's what I would do.
angle ABC and well. I was trying to say that like ABC and like A and D, like that angle down there would be congruent.
This one,
No, like the other one.
this one.
Yeah, I don't know if that's the way you want to.
Yeah, there's multiple ways to do this.
Well, I don't
work.
want to go my way necessarily.
No, I mean, they're all about the same.
Okay, good, sure.
So she said, I know this angle CBA is also congruent to this angle down here, DA, put a dot on there, call it E, whatever you want. How do I know those are congruent?
Because they're
Alternate, no.
corresponding.
Corresponding angles. So you could say by corresponding angles. You could also do this with alternate interior angles. You could also do it with alternate exterior angles. Like all of these work. Okay, so if we do corresponding angles, we're going to say angle CBA is congruent to angle DAE by corresponding is it postulate or conjecture?
Unless there's two of them. It's a.
No, postulate, you're right. Up there. Oh, no, we're up on parallel lines, it's conjecture, corresponding angles conjecture.
What's the difference?
Where's the other one?
Under general.
It doesn't matter. Honestly, whenever I write it, I try corresponding angles. I think that this is what when we do parallel lines, we start off with this conjecture and then we prove it and it becomes a postulate later on. So it's like if we were making this as we went, we would start off with just that and then it would turn into a postulate. By corresponding angles. Okay, so how does that help?
Yeah, and you know that EAD and BAD.
So she said this angle right here and this angle right here. What do we know about them?
They're
They're a linear pair. So angle EAD and angle BAD are a linear pair.
so
What does linear pair mean?
means that they equal 180.
So I'll write that measure of angle EAD plus the measure of angle BAD equals 180 degrees. By, that's definition of a linear pair. What are you gonna say, Carrie?
Is it BAC or BAD?
BAD. Basically there.
So
I'm really close. I had BAD, DAB. They're the same thing, right? These match. This is CBA and that's EAD.
So since EAD and wait, whichever that one was, since CBA and DAE are congruent, that means that.
Yep, I'm gonna use this idea. Since these are the same, can't I replace, I wrote these backwards. Can't I replace this with that?
Yes.
Now I can say measure of angle CBA plus measure of angle BAD equals 180 by, what did I just do? Substitution. And we're done, right? Because that's what I need to get there. Like, that's what I just showed.
You just do it for the other side, or do we even have to?
So real fast, let's finish this. Like, we didn't quite finish the words. So I have that, and now I can say, actually, no, that would be good enough. So technically, if I was trying to prove, if my goal was to prove exactly 2 pairs of consecutive angles are supplementary, I would technically do the same thing on the other side now. We're not gonna write all that, but the idea would be you would then say it on the other side, and then you could apply that to any trapezoid ever. So that was using corresponding angles. You could do the same thing with alternate interior angles. If you were gonna do with alternate interior angles, which 2 angles would you use? There is multiple answers here also.
Wait, if we're gonna use which one,
Alternate interior angles.
then you would do like the angle C and angle B. Yeah.
Let's still do it over here with these 2. Let's like redo the proof with alternate interior.
Angle. EAD and.
That's an exterior angle.
Oh, my bad. Angle A and angle B, did you say that?
So if you were gonna do alternate interior angles, you're doing the 2 sides of the Z. So it's like, if I'm doing this one right
Yeah,
here, I'd have to do this one over here.
Could I just call it A and B?
Well, yeah, you'd have to put a name on, point and call it whatever you want. So you could do those 2 and say, well, that's congruent to that, and those had to be 180, so that plus that has to be 180. Or you could do it the other side, you could do this one over here. You could also do alternate exterior angles. This is congruent to this, that is congruent to that, so on and so forth. Okay, so do you see how it doesn't have to be this exact version? So there's not necessarily no, there is a wrong answer, but there's multiple right answers. How about that? Okay, so we did that one. Check. What next? Let me see what else I want to do. Let's move over. We're not going to go into the specifics on here. Oh, real fast. Remember last time when we were kind of questioning, does a right trapezoid have 1 right angle or does it have 2 right angles? Remember when we were writing that, we were trying to decide, does a right trapezoid have 1 right angle or 2 right angles? I thought I wrote that down.
The definition says just say exactly 1 angle.
Let me see, what did we write? Where is it? What does it say? Has exactly 1 right angle?
Well, I only wrote down the definitions for parallelogram, trapezoid, kite, rectangle, square, and rhomb, set it right down.
I remember thinking about this last time about, does it have more than 1 right angle or just 1 right angle?
We just have 1 angle.
We just proved that they have to be 180. If one of those is a right angle, when you have another one.
Look at the. I'm gonna say no. Because then we just be a square?
No.
Oh, wait, yes, yeah, okay, yes.
So we just proved
I'm
that
with you now. So
these 2 had to be 180, these 2 had to be 180 forever, no matter what. Agreed? So if this one's a 90, that one also has to be 90.
Yeah, I got you.
Or not at the same
I
time.
thought you were asking if there's two pairs, like.
No,
there were
no,
two
no.
pairs.
One pair. If this one's 90, that one also has to be
Yeah.
90. So technically that right trapezoid has two right angles. They just have to be placed here or here. That was something somebody asked last time. I don't remember who asked it. You asked it. I remember thinking through it and thinking about this and making that answer. So I just wanted to make that connection. Let's talk about parallelograms. Look over at parallelograms. Opposite sides or parallel, what is do we have a definition here? The definition is two sets of parallel lines is our definition, right? So none of those is our definition. These are all just like characteristics that we can use. We're not gonna do all of them, but look at number 6. Consecutive angles are supplementary. Isn't that what we just proved? With a trapezoid, it's the same idea for parallelogram, but this time for a parallelogram, I actually have two sets of parallel lines, so I can prove it on all sides here. So we're not gonna do that because we've kind of already done that proof. We don't really need it again. Both pair of opposite sides of parallel. Let's do that one. So number one.
Like a test, if we proved the proofs for a trapezoid, could we not say refer to, or do you want it all wrote out again?
I'm not going to do it. Don't worry about it. I'm not gonna, like, on your test, I'm gonna pick 2 proofs and they're gonna be 2 easy versions that we've already done. I'm not gonna hold you to this very, very high standard. Okay, I just want you to show me you know how to prove things. What's that look on your face, Jamie?
No, I don't remember what you said. What are we proving and
The
what?
first one, number 1.
Okay, this is the definition.
Definition is 2 sets of parallel lines.
Oh, we're trying to prove it. Well,
Oh, I'm sorry. Yes, thank
So
you.
we're gonna prove
That's
number
what, we're gonna prove number 2. Number 1 is the definition. Sorry, I read that as congruent, not parallel. So number 1 is the definition. We're gonna prove number 2, that the opposite sides are congruent. So let's draw a parallelogram. So parallelogram again is just 2 parallel lines, 2 sets of parallel lines. Don't make it look like a rhombus or a square. Because you might start making assumptions otherwise. A, B, C, D. We proving angles or sides first? Sides. Okay. So what's our goal?
prove that. AB equals DC and DC equals AD. Right.
Mhm. A, B equals,
Or
yes,
congruency.
yes, yes. Sorry, I'm thinking ahead right now. I'm trying to plan ahead. Give me a second. Any ideas on how we are going to do this? Oh, I got it. I was trying to get the answer in my head before we start working.
Yeah, I don't know.
Got it. Okay, so what do we know that what do we have here? What do we know about parallelograms?
2 sets of parallel.
Parallel lines, right? So I know these are parallel. I know these are parallel. My goal is to show AB is congruent to CED and also BC is congruent to AD. Let's do one of them and then the proof would be the same thing to finish it out, right? You do it again using the opposite stuff. Okay, so let's pick one. Which one do you want to do? Doesn't matter.
AD and B.
AD, so our goal is AD is congruent to BC. And if we show that, we are done. Check. Okay, so based off what we know, you can kind of go about this two ways. You can work backwards or you can work forwards. And obviously we're gonna meet in the middle. Let's think through working forwards. What do we know here? Parallel lines. What information can we glean from parallel lines? Yes.
I don't know.
Good job, Vivian. They're never gonna touch, correct. What else do we know about parallel lines? We have like a word bank that has a whole section of parallel lines.
That,
Corresponding angle.
Angles, angle, right? So I can figure out stuff about angles here. Everybody agree? My goal is not angles.
We
Right?
could switch to angles.
Huh?
We could switch it to angles.
That is one of our things, and that's actually what we usually do first in here, but we decided to get sides, that's fine.
I take it back.
Go ahead, take it back. Okay, so our goal is to get to sides. We have to start with angles, okay? Let's go the other way. We're trying to prove sides are congruent. In what ways in the past we proved that sides are congruent? Sides, we're going backwards now. Start at the bottom.
via.
Trying to find our problems we just did to show you how we just, this one? Got too many papers around here.
Triangle, are we ever gonna do the triangle thing?
Yeah, triangle thing. So we've been showing sides are congruent by CPCTC, right? And first we have to get congruent triangles. Let's make some triangles out of that.
You split
Split it how?
B to D.
B to D. So I'm gonna split it B to D. That is a diagonal. Agree? So now,
Angle. A. B. B and. C. D. B. Wait, no, anyway. Someone else can talk, I'm on. I really don't.
stay out.
Do angle AB and then, like, I guess it would be ABD.
Mhm.
Isn't that one a 90-degree angle, like both those connected, don't those make a 90-degree angle?
No, not on parallelogram. If this is a rectangle, yes, or a square, yes, but not for parallelogram.
How about ABD?
ABD.
Equal to CDB because.
Yeah, turn it this way. Aren't those alternate interior angles on a set of parallel lines? Good job, guys. Good job. So we know, okay, so first of all, we need to say AB is parallel to CD and BC is parallel to AD. And that's by definition of a parallelogram. And then now I can say angle ABD is congruent to angle CDB by alternate interior angles conjecture. We do usually abbreviate that one, AIA. I got one set of, so far, my goal to prove triangles, I need three things, right? Some set combination of angles, sides that don't spell ass, right? So I have an angle so far. What else do I
And I
know?
also know that BD is,
BD is congruent to BD.
Yeah.
Right? So I have a side too, or a side also. We know that BD is congruent to BD because it's the same segment. So I have an angle on the side. Pick another side with an included angle, or it's not gonna be another side. The reason why it's not gonna be another side with an included angle is because the sides is our goal. My goal is to show both other set of sides. So it's like, it's gonna be another angle somewhere.
when you CBD and ABD.
She says we can do CBD and ADB. How can I do those? Same thing. Same thing with the other set of parallel lines. We used these two sets of parallel lines the first time. We're now going to use these two sets of parallel lines this time. Those are also alternate interior angles. So we can say angle CBD is congruent to angle ADB by alternate interior angles.
Let me put that triangle ABD and CBD.
Yep, now we did angle, aside, and angle. And we can say triangle ADB is congruent to triangle ADB CBD by angle side angle conjecture. And have we finished? Did we meet our goal? Can we say AD is congruent to BC now?
Yes.
Now we can say AD is congruent to BC by CPCTC. And remember how I said, technically we need to do both sets of sides? Did I do both sets of sides this way? Can't I now also say AD, can't I also say BA and CD? Because I did both ways, so technically you could get both of them that way. A, B is also congruent to C, D. So check, we proved that opposite sides are congruent. Did I also prove number 5, opposite angles are congruent? I have two congruent triangles. Can I say BAD is congruent to BCD? Yeah, because those are opposite angles. I can also say and angle BAD is congruent to angle DCB by CPCTC. If you're going to do opposite angles, this is the one you would have to do 2 different versions, because I just proved that these 2 opposite angles are congruent. I would now need to do the other diagonal and prove it the other way also. Technically, we're not going to do it now, but that's how you would prove both sets of opposite angles are congruent. So we did 5. We basically did 6, right? I'm not gonna spend the time doing 6 because we did it for a trapezoid, and this is just a more specific version of a trapezoid, right? It's 2 sets of parallel lines instead of 1 set of parallel lines. If I could do it with 1, then I for sure could do it 2, is the idea. And I think we could also say we did 3. Didn't I show just now that one pair of opposite sides are both parallel and congruent? These are parallel and these are also congruent. These are parallel and these are also congruent. So technically that version I just did number 3 also. Last one we're going to do is this diagonals bisect each other. I don't have this written down, but I have full faith we got this, guys. So diagonals bisect each other. Let's do the same picture. I have to put in the other diagonal. So the other diagonal would be here. I'm probably going to use some of this information. So I'm going to leave all that there and I'm going to say refer to above if I need to, right? So diagonals bisect each other. What is our goal if we're trying to show that the diagonals bisect each other? Let's see if we can get this done in 7 minutes. I don't know. We'll see.
You trying to prove that?
These 2 are congruent. These 2 are congruent, right? If I bisect, it means it splits this line in half and splits this line in half. So my goal here is trying to like make it all 1 page. My goal here is that, oh, I need to make a name for the middle. I'm gonna call the middle E. So my goal here is that, down here, BE is congruent to ED And AE is congruent to EC. Yep, I have lots of different triangles there. Which triangles do you think we might want to use looking at our end goal with our letters that we're trying to use here? The thing about doing AED and the bottom and the top, AED, I'm trying to do BE. I need that chunk, and those aren't connected. So if you do this version, or we might have to do both. I don't know. I haven't done this yet. I don't have it on my paper, so I'm playing it by ear.
So, yeah.
So can I prove those two triangles are congruent? What do I
Yeah.
know?
Angle,
Yes,
side,
could-
angle.
Angle, side, angle.
Angle.
Where's the third angle?
Because we already proved that angle ABD was congruent
Yep.
to, and then that
Yep.
ADB. So we know that those angles, and then it shares the side.
I'm talking about this triangle and this triangle. They don't share a side.
Oh.
But I do have these congruent angles.
And then E had.
This is a vertical angle, right? That should be a 2. That should be 3. I already did 2. So those are vertical angles, right?
So it's gonna be angle, side.
My side would be this
Or
side.
Side angle. Which one do you want us to use?
Doesn't matter. So this would be my side. I've already proved opposite sides are congruent based on this, right? So I would say AB is congruent to CD by that proof above. I'm gonna put an arrow showing the proof above. I know that angle ABD is congruent to angle CD. This should be an E actually, sorry. ABE, CDE by, how do I know those angles are congruent?
Vertical ones.
I'm talking about these two ones that we already have.
Above.
From above, or you could also say angle, no, I'm sorry, alternate interior angles is what we actually said originally.
Okay.
So those are my side and an angle. My other angle, I could say, you could actually say this other chunk. Nope, we didn't prove this, never mind. Let's do the vertical angle. So angle BEA is congruent to angle BEA CED by vertical angles conjecture. And now I can say my triangles are congruent by angle, angle, side, side angle, angle, doesn't matter how you write it. Now I can say triangle BED, nope, A, sorry. BEA is congruent to triangle BEA DEC by angle, angle, side, side angle, angle, it doesn't matter how you write it.
So now we know BE.
Therefore, BE is congruent to DE. I'm gonna go do the other one also, and AE is congruent to EC by CPCTC. That wasn't bad. Since we already had all that written, it wasn't bad. And that was the diagonals are bisect each other. So check, we did all parallelogram stuff. Okay, so we are going to stop there. Next time we are going to move into some flowchart proofs. So getting a little more specific with the proofs instead of being so wordy, we're gonna make them a little more efficient. You have 2 homework assignments. Oh, I said next time. Oh, sorry. Samantha, sorry, I just saw that you're in the waiting room. So next time we're actually doing GeoGebra. So make sure you have a device next time. And then Tuesday, we'll move into flowchart proofs. And you have 2 homework assignments right now out. And they're not proving stuff. They're just working problems. So see y'all on Thursday.
Hello.
Hey, Samantha, sorry. How long were you out for? The
I
whole
would say-
time?
Yes, ma'am. As soon as it started, the parallelogram, it went out.
Oh, okay. That's no problem. Hey, I actually recorded this for somebody else. I can send you the recording and then you can just fast forward until you need to.
Yes, ma'am.